Hi everyone, welcome to my channel Concept Learning. This is Rasagnya. So in my previous classes I have taught you about 3D geometry, the basics of 3D geometry and about DCs and DRs, and I have also covered the topics or most of the topics about 3D planes. And in my previous class I have told you that if I have left any 3D geometry plane topics, then I am definitely going to cover it in this class, right? So I left foot of the perpendicular image concept. Those two are really very similar to the 2D geometry line concept, but I must tell them because they are the topics of 3D geometry, right? So let me tell you about those things, okay? So guys, what is foot of the perpendicular actually? What is it? You have read it in 3D geometry, right? So what is it? If I take a line ax plus by plus c equals to 0, and if there's a point above this line, that is x1 comma y1, okay? So if I draw a perpendicular line from the point x1 comma y1 to this line ax plus by plus c equals to 0, what will happen? This is the perpendicular line, right? So this perpendicular line meets this ax plus by plus c equals to 0 line at some point, right? So this point is known as the foot of the perpendicular of this point on this line, right? So there's a formula for this you have studied in 2D geometry. So the same concept is when we study about the plane's foot of the perpendicular. Now what is that? If this is a plane, okay, and there's a point here that is x1 comma y1, okay, and if this plane's equation is ax plus by plus cz plus d equals to 0, okay, and I have drawn a perpendicular line from this point x1 comma y1 to this plane. Okay, this is the perpendicular line. Okay, so now this is the foot of the perpendicular because at this point this perpendicular met this plane ax plus by plus cz plus d equals to 0. Okay, so now what's the formula for that? It's same as in the 2D geometry, but as you know, one term is added. Okay, now what is that formula? It is okay, so this is 3D geometry, sorry. So there will be a point z1, right? And let me think that this foot of the perpendicular is h comma k comma something l. Okay? So now the formula will be h minus x1 by a is this one, is equals to k minus y1 by b plus l minus z1 by c. That is equals to minus of ax1 plus by1 plus cz1 plus d by a square plus b square plus c square. This is like this, but if your equation is of the form ax plus by plus cz is equals to d, then definitely you will bring this d this side, then your equation will become ax plus by plus cz minus d equals to 0, and you are going to put x1, y1, z1 in this equation. Okay, if your equation is like this. Okay, clear? So this is the formula for the foot of the perpendicular. Everything is same as in 2D geometry, but we have, this is equals to, and this term and this extra terms, these are only added, okay? Only the z terms, z coefficients are added, that's it. Remaining everything, the formula is same. And what is an image of a line? This is also very similar to the foot of the perpendicular. If this is a line and I want the image of this point, right? So if this is the perpendicular line and if the foot of the perpendicular is the midpoint from this point to this point, the next point joining. That will be the image. This point will be the image. Okay. When I draw the perpendicular line, if this there's some point, if we mark a point, and the foot of the perpendicular must be the midpoint to these 2 points. That will be the image of the point. That is, the distance between this point and these 2 points must be the same. That will become the image, right? So in the same way for the plane also. Okay. Then what will be the formula for that? You will write the same formula over here. Right, and the same plane equation, ax plus by plus cz plus d equals to 0. And what will be the formula? Even in 2D geometry, what will you do? You will just put 2 over here, right? That's it. Why did you put the 2? Because the distance is doubled. The distance from here to here is some b. Then the distance from here to here will be 2b, right? Because it is twice. So because of that, we are also multiplying 2 to this, right? You have learned the same in 2D geometry. So this is the only concept that was left in planes. Now we are going to jump into some new topic in 3D geometry, that is lines. You will think lines is a very common concept, right? We will also learn it in 2D geometry. But a line in 2D geometry is different from a line in 3D geometry. Let us see how that is. So guys, let's learn about 3D line. So don't think that 3D line is something that looks different from a 2D line. No, it looks the same. But the way that we represent it is very different. Okay. So generally if you look at a 2D line in your XY plane, that is, this is Y and this is X plane. When you look at axis, about this X and Y axis, that is in 2D geometry, your line will be like this, something like that. Then what do you write the equation of the line as? You will write it as ax plus by plus c equals to 0, right? It is similar to the equation of the plane in 3D, leave all that. But when you come to the line in 3D geometry, it's totally different. Let us look how does that look. If this is the 3D coordinates, that is x, y and the z coordinates, okay, then how does the equation of the line that is in 3D geometry look like? How does the equation of this line look like? It's very different, but let me tell you the general form of that line. That will be like this. If there's a point x1 comma y1 comma z1 on this line, if a point is situated, then x minus x1 by a plus y minus y1 by b plus that is equals to z minus z1 by c. This is the general form of a line equation. Okay. So what are these A, B, C? These are the DRs of the same line, because we already studied that a line has DRs, right? So in case of a plane, because a plane does not contain any DRs, we take the normal DRs. But this is a line, so this contains DRs. So we put the same DRs A, B, C. Okay, these are the DRs of the line itself. Okay, and this x1, y1, z1 is the point through which the line is passing. Okay, alright, have you all got it? So now there are many other concepts that we need to learn when we are learning about lines as they are in planes. So at first, let us look about the angles between two lines. Okay. So guys, what is the angle between two lines? It is too similar to the angle between the planes. Not similar, the same formula. We use the same formula. If these are the two lines, then to find the angle between these two lines, if the DRs of this line is A1 comma B1 comma C1 and these lines are A2 comma B2 comma C2. If these are the DRs of the line that we need, the angle between the lines, right, we need. So, if these are the DRs of those lines, then the formula is the same, ditto formula. That is cos theta is equals to A1 A2 plus B1 B2 plus C1 C2 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. The same formula we are going to use, but there the DRs are of the normal of the plane, but here the DRs are of the line itself. Okay, that is very simple, same as that we learn in the plane concept, right? So guys, the general equation that we write for the line that we have learned now, what is it? X minus x1 by a plus is equals to y minus y1 by b, that is equals to z minus z1 by c. Is this the equation that we have learned before? Yes, that is true. This form is called the symmetrical form. What is it called? The symmetrical form of a line. Okay, symmetrical form of a line. Then we have another thing that is called unsymmetrical form. Now how does that look like? It looks like we add two equations of the plane. We put two equations of the plane in that. That looks like u1 is equals to 0 equals to u2. Now what are these u1 and u2? These are the equations of the plane. Now what is this unsymmetrical form actually? Why do we write it like this? That is because if there are two planes like this, like if you have a book, like this, okay, if this is one plane and this is the other plane, then when these two planes intersect, there's a line forming here, right? If this is one plane and this is the other plane, there's a line between these two, intersection line. When two lines intersect, we get a point of intersection. But when two planes intersect, we get line of intersection, right? So this line of intersection, when we want to represent, we represent it in this form. Now what are these u1 and u2? u1 is the equation of this plane, u2 is the equation of this plane. Now to write the line of intersection, we use this unsymmetrical form by using the equations of these two planes. Okay, but it will be difficult for us to do the sum if it is an unsymmetrical form, right? So for our convenience, we change this unsymmetrical form to the symmetrical form of a line, okay, to make our sums more simple. Okay, we do any sums using this symmetrical form because this is the most familiar form. Okay, so even this form could be converted into this form, but how do we do that? I'll just show you now. If you have two equations of two planes, that is u1 is equals to something like a1x plus b1y plus c1z plus d1 is equals to 0. This is u1. And u2 is equals to a2x plus b2y plus c2z plus d2 equals to 0. This is the u2 line. Okay, clear? So now, what is the unsymmetrical form of the line of intersection between these two planes? That will be u1 equals to 0 equals to u2, right? So how do you convert this to the symmetrical form? That is the question. Okay, let me tell you. So let me draw them for you on the board. That is, they are like this. I am drawing a very rough figure. Okay, these are the planes, that is u1 equals to 0 and u2 equals to 0, and this is the line of intersection. Okay, now listen to the process very carefully. If I draw a normal to this plane, how does this normal look like? It looks like this. I'll draw it like this so that it looks perpendicular somewhat like this. Now this perpendicular line is also perpendicular to this line, right? This perpendicular line to this plane, that is normal to the plane, is also perpendicular to this line. Am I right? So if this is the normal, the drs of the normal we already know, that is a1, b1, c1, right? The coefficients of x, y, z are nothing but the drs of that plane, right? Drs of the normal to that plane, right? So the drs of this normal to this plane u1 equals to 0 are a1 comma b1 comma c1. If I think, for example, the drs of this line as l comma m comma n. Okay, now this normal of this plane is also the perpendicular line to this line, right? So I can write perpendicular condition to this both. So how do I write it? LA1 plus MB1 plus NC1 is equals to 0. Perpendicular condition completed. Now let us look to U2. The same condition applies over here. If I draw a normal to U2 like this, if this is the normal, this line will also be perpendicular to this line. So what are the drs of this normal? A2, B2, C2. So A2 comma B2 comma C2. Now if I write the perpendicular condition to these both also, what do I get? LA2 plus MB2 plus NC2. Am I right? Now I know A1, B1, C1, right? If they give you two plane equations, you know these A1, B1, these are not variables for you. You know those already, those are constants. So for you to find these L, M and N values, so you need to solve these two equations. After solving these two equations, you will be getting the value of L, getting the value of M and getting the value of N2. Okay? And okay. So now, if I get the values of L, M and N, to write it in symmetrical form, these L, M and N are the drs of the line. Am I right? So what is the general form of a line actually? X minus x1 by A, y minus y1 by B, z minus z1 by C, right? So what is this ABC? Drs of the line. So I have got the drs of the line L, M and N, some values for them. So I'll put them over here. L, M and N. Those values I'll put over there. Okay. So now the only thing that is unknown to me in the equation is x1, y1, z1. Am I right? So how do I find that point x1, y1, z1? So here I will make a small assumption. That is, I will make any of the coordinate x1, y1, z1. Any one of them, I will make it 0. Okay. So first suppose I will take z1 as 0. Okay. Then what will be that point? It will be x1 comma y1 comma 0. This will be the point. Then if this point lies on this line, on the line u1 equals to 0 equals to u2. If it lies, then it will be over here somewhere. That is x1 comma y1 comma 0. Okay. So now, because this line is the point of intersection of both these planes and that line lies on both the planes, so this point also lies on both the planes, right? Am I right? So I can substitute this point in these two equations and those satisfy the point, right? Because that point lies on both the planes. Then what do I get? I get a1x1 plus b1y1 plus, since the z1 is 0, c1 into 0 plus d1 equals to 0. Am I right? So now, if I substitute the same point in the second equation, I get a2x1 plus b2y1 plus c2 into 0, z1 is 0, plus d2 equals to 0. Okay. So I get two equations, right? a1x1 plus b1y1 plus d1 equals to 0 is one equation, and the other a2x1 plus b2y1 plus d2 equals to 0. This is the second equation. Now, if I solve both these equations, what do I get? I get the values of x1 and y1. Am I right? I get the values of x1 and y1. I already know that z1 is 0. I assumed that. So then, I will get this point x1, y1, z1. That is, I will get some value of x1, some value of y1, and z1 is 0 anyways. This will be 0. Okay. So, that will be my required equation. Are you clear? You will be getting more clarity about this type of problems when we start doing the exercise problems or model problems, okay? So then you will get more clarity about such problems, okay? So now this is one concept. Now let us move to another concept, that is how to find the foot of the perpendicular of a point on a line, on a 3D line, okay? On a 2D line you have one formula, and on a 3D plane you have one formula, but for line in 3D you don't have any such formula. You need to do a simple process and I'll tell it to you. So let us look how to find the foot of the perpendicular of a point on a line, okay? So guys, now let us look how to find the foot of the perpendicular of a point on a line, okay? So now let us represent that on a board, okay? You should imagine, and I'll also put it on the board, okay? So how to do that? If this is a line required, let that line be, I'll take the general form of the line, that is x minus x1 by a equals to y minus y1 by b equals to z minus z1 by c. Am I right? So now there is some point over here, that is x1 comma y1. Okay, I already have here x1 y1 z1, right? So let me take L comma M comma N. Okay. Let this be any point on point over here. Okay. Now I need the foot of the perpendicular. What is the foot of the perpendicular? If I draw a line perpendicular from this point to this line, this will become my foot of the perpendicular. Am I right? Yeah. So how do I find this point? So there's a small procedure for that. Let me tell you. What is it? The first thing that we do is we'll take this equation. We have this equation, right? So I'll equate it to some constant r. Okay, because you know they are in the same proportion, so that we wrote the equation like this. So I'll equate it to some constant. Okay, that will be k. Let me take it k. Okay. So now what must I do? I must just find the values of x, y and z in the terms of k. Okay. I must find the values of x, y and z in terms of k. How do I do that? If I take this and the constant, I get x minus x1 equals to ak, and my x is equals to x1 plus ak. Am I right? Now let me find y in the same way. I get y equals to bk plus y1. I'll write directly. Okay. So z is equals to ck plus z1. This will be my x, y and z, right? So if I write it like this, this x1 plus ak comma bk plus y1 comma ck plus z1 will be one general point on this line. Okay, because I put one constant and multiplied with that. So I will get a general point on this line, that is this one. Okay. Now because that is the general point, let me think that this is that point, that is x1 plus ak comma bk plus y1 comma ck plus z1. Okay. So now I know this point. So for me to find the drs of this perpendicular line, what must I do? I have already previously told the formula to find the drs if I know 2 points. x1, y1, z1, x2, y2, z2. What will be my drs? x2 minus x1, y2 minus y1, y2 minus y1, z2 minus z1. Am I right? So in the same way, now if I do if I apply that formula over here, that is x2 minus x1, y2 minus y1, z2 minus z1, what will I get? x1 plus ak minus L. This is x2, y2, z2, x1, y1, z1. Okay. Comma bk plus y minus m, comma ck plus z1 minus n. Okay. So this is the pair of drs of this is the set of drs of this perpendicular line. So we know the drs of this line, right? What are those? A, B, C. Those are the drs of this line, right? So I know the drs of this line and this perpendicular line. Now I can apply the perpendicular condition over here, right? So here the only unknown variables I have are only k, x1, a, l, m, and you know all those values. Okay. The only unknown thing is k. So now if I multiply this thing with this, what do I get? Then I get because those are perpendicular, if I multiply and add all of them, I will get 0. That is a perpendicular condition. a1, a2 plus b1, b2 plus c1, c2 equals to 0. I have told it previously. So what will that be? A into x1 plus ak minus l, comma, plus b into bk plus y1 minus m, plus c into ck plus z1 minus n equals to 0. Here all are known variables except the k. So you will definitely get the value of k. Then if you get the value of k, you will just substitute that in this point. Here also except k, all are known variables. So all are known things, okay. Sorry, variable means unknown, right? So remaining all are known except k. So here I will get the value of k. I will substitute that k. Then I will get that point. So then I will get the foot of the perpendicular. So guys, that is the way to find the foot of the perpendicular of a point on a line, on a 3D line. Okay. So now I can also find the image of the point. We have already found the foot of the perpendicular. Now I can also find the image of a point. Okay. Now how do I do that? The same thing. I have the line, right? And there's a point something like x1 comma y1 comma z1. Okay, I have the line equation something. So by using the same procedure, I will find the foot of the perpendicular. Okay, let me think that the foot of the perpendicular I got is h comma k comma l. Okay, if I get this as the foot of the perpendicular, then how do I find the image? I already told you that the foot of the perpendicular will be the midpoint of the point given and the image. Am I right? So let me think that this image is L comma M comma N. Then how do I get that? How do I use that midpoint formula? I will use it as x1 plus L by 2 equals to h, and y1 plus M by 2 equals to k, z1 plus L plus N by 2 equals to L. Okay. So that is how I do this. Okay. Let me think that this point is L dash. Yeah. L dash. Okay. So this is how I find the image of the point. So guys, I have told you how to find the foot of the perpendicular and how to find the image. Okay. So these are the concepts that that are there in 3D geometry, including the lines and planes. I have covered most of the topics. If any are left, I will cover them in the next class. So actually I have told you that after the concept I will be teaching IP sums. But in 3D I am not going to do so, because Previously, when I started 3D geometry, I have already told you that imagination is most important for doing 3D. So in my next class, what I'm going to do is, I'm going to write some sums on the board and I'm just going to tell you how to imagine those sums, okay? So after that, I'm going to teach you sums of IPA and the competitive exams, okay? So guys, do not forget to subscribe, share and like the video so that I'll stay motivated and do more and more videos for you. Also, do not hesitate to put the topic that you required in the comment section below so that I'll make the video of that topic also. So thank you for now. Meet you in my next class. Bye bye.